are ones that make sense. These are ones that you use. These are ones you've probably used in science before. You've done any population studies, in I don't know, social studies type classes maybe. But anything that's exponential, radioactive decay, you guys will probably see that here in chem. When you're dealing with finances, when you're looking at bank accounts, how fast how money accrues, how fast things depreciate. You know what that means, right?
Yeah.
Depreciate means you don't really like it. Is it depreciating if you like it? No, depreciation is when something loses value over time. You know, for example, cars. You could buy a car for $40,000, and the minute you drive it off the lot, it's worth less.
We just got that lesson.
Yeah, sorry. So what happens here, we're going to talk about, to start with, the growth model. The growth model is modeled out of this style of an equation, where this A value is your initial amount. Your R value is your rate, and we use it in decimal form. And then T is your time.
Oh, so I should have T as the orders of magnitude. Can I put X for T?
You can, but we use T because it's denoting time. All right. You'll see how it plays out real fast here. It's pretty obvious how this works. You've got what's called the growth factor. The growth factor is the 1 plus your rate. Okay. It's very, very easy to work with these. So let me show you an example of how this stuff looks. Let me leave this written up here. So we've got growth. The most difficult part of this is usually converting a percentage to a decimal. 63% is?
460.
Very good. So let's look at this one. Population. The population of some place in Nevada, I don't know, is given by this model. P equals 6191 times 1.04 to the T, where T is the number of years since 1990. So 1990 is your first year. Okay, it's year 0, if you will. So if 1990 is your year 0, it's a Smashing Pumpkins album, isn't it? Year 0? No, it's Nine Inch Nails song. Their album. It's Nine Inch Nails album. If your year 0 is 1990, what's your initial amount?
191.
If year 0 is 1990, what's the initial amount?
6,000.
There's your initial. So your A value is 6191. There's your initial amount. Remember, if T is 0, that means it's 1.04 to the 0. What's anything to the 0 power? 1. So therefore, that means that's your initial amount. That's how that works.
What?
What's anything to the 0 power, is it?
What?
So what's 1 times 6191?
What? I mean, I just
There you go. How does that, I'm just telling you that's what it is.
Okay.
Okay. Now, what is the percentage of increase here?
1.04 or 4%.
It's 4%. Okay? Because this can be broken into 1 plus 0.04, therefore it's a 4% increase. Okay? You'll see it like that, and that's usually where people mess up, where they'll ask you, what's the rate? And you might accidentally just say, oh, it's 0.04%. Well, 0.04% would be 0.0004. See what I'm saying? It's just those little things, so you just got to be careful with it. So when we're looking at this, excuse me, the initial amount in 1990, well, there you go. And what percent did it increase by? 4%. So what would you do if I wanted to know what was the population after 10 years?
Put 10 in the...
Exactly. You put 10 in for T. And you see where they're saying like T is in years, so T is your time. That's why it's they keep it as the T like that. So if you put that in your calculator, all you have to do is wait for the calculator to turn on.
Nice. Clutch.
There we go. Come on now. Hello, computer. There we go. So 61 to 91, parentheses 1.04, parentheses to the 10th. And you type it in exactly like that.
That's
So-
your answer.
and that's your answer. So your population after 10 years would be 9,164.
And one.
No, you can't have that much of a person.
You have 0.19 of a person.
That's why I said.
I mean, it's
Maybe-
an R.
Maybe somebody that cut off like their left hand.
It's possible, but in terms of people, you might want to round the nearest whole person.
Yeah, maybe.
All right? Depends upon what the problem's asking. He dies in the end, you know that, right?
Who?
No, I'm not.
And
Huck
what?
Finn dies at the end, you know how?
Are you serious?
He jumps off the back of the boat because he tries to run through the paddle wheel. And he kills him.
Oh, yeah. Yeah, we I knew this guy died. That's why he comes like, I'll be back.
Let's talk about money. This is what I like more about with these things.
He doesn't die.
He doesn't die. I'm making stuff up. He's I'm a fibber. All right, compounding interest. You might have seen this before as well. You got your econ book here. You've probably done this, right? You talk about interest stuff. So again, this value of P is your initial amount. It's called the principal. It's still your initial. R is your rate. Again, it's going to be as a decimal. The value of N is the number of times it compounds. Here's what that means. It'll say it compounds yearly. It'll say it compounds quarterly, semi-annually, daily, monthly, all of those things. We're looking at this in terms of years. That's why they say it's the number of times it compounds per year. So if it says that it compounds quarterly, what would the N value be? 4. If it does semi-annually, what would it be? 2. If it's daily, it would be 365. Okay, Mr. Smarty Pants. Generally looking like that. Now, excuse me. And then the T value then is just the number of years.
Yeah.
Yeah, I'll write it up on the whiteboard as well. Compounding interest, once again, is an extremely easy thing to use. It's just a matter of remembering the formula. So your overall amount is equal to the original amount, your initial, your principal, 1 plus your rate divided by the number of times it's compounded to the number of times T. When you go through a problem like this, again, you're just using your calculator. It's not that I can't take your calculator away from you to do something like this. I mean, you could, but that's really, really, that's kind of. Let me show you an example. So if you want to put in $1,000 into an account that pays 8% annual interest, find the balance after 1 year if the interest is compounded with these different frequencies. Frequency in this case, number of times. Annual, quarterly, or daily. So formula-wise, your amount is your principal, 1 plus your rate divided by n to the t. So what's your principal for all of these problems?
So that's what you start out with?
Yeah. Your principal is always what you start out with. It's your initial amount. What's your rate as a decimal? 0.08. And now if I want to do annual, what's n? 1. Okay. What's our t value? This problem's asking all this info be after 1 year, correct? So we'll just say t is going to equal 1. So now we have an n equal 1. When it's quarterly, what does n equal? 4 and daily. Now, what's nice again about doing this type of a problem, was it 1,000 parentheses, parentheses, 1 plus alpha y equals, our rate was what, 0.08?
Yeah.
8 over 1. Close it to the, well, this is really just going to be 1.
Do you have to put that?
Well, I'm going to do it like this because by putting it in the calculator like that, when I go back to change everything out, you can just overwrite it. Have you guys ever done that before?
Oh, yeah.
It's the easiest way to do it. So after 1 year, if it just compounds that one time, you made an extra $80. Yay!
Wait, can you go back a little?
Oh, I didn't even see the, yeah.
Oh, I thought, yeah. I mean, if you think about it, if you're getting 8% interest on something that was $1,000 after a year, what's 8% of 1,000? $80. Yes, sir.
Instead of 0.08, should you just put 8%?
Don't like pressing percent buttons. Everybody always does it with a decimal. I think you could probably, I don't even know where the percent button is on this calculator.
It's,
You know what I'm saying? Takes too long to find it.
Just put the decimal.
So what I mean by overwriting it, the only thing that's going to change in this next one is the end value is going to change to 4. So when you do that in your calculator, if you haven't done this yet, what you do is you hit second equal, and it brings up what you just typed in, and just change those values. Just backtrack it. I know I'm going to have to change that one to a 4, and I have to change the denominator also to a 4. And I hit enter.
Wait, would you second enter and that's
Yes,
what
sir.
brought it down?
Yep, it just rewrites it, it just pulls it. Because if you look at the blue value on the enter button, we hit second, it says entry, that means what you just typed in before it. Does that make sense what I'm doing there, just by overwriting stuff? It just saves you time from pressing buttons on a calculator. I know, you guys are all about time saving. Yes, ma'am?
So like, is that the answer?
Yeah, so after a year, if it compounds quarterly, you'll make $182.43.
Wait, what does it mean?
I meant $1,082.43.
What does it mean to compound? Like, I don't get what that is.
They're calculating the interest a certain amount of times. When interest is compounding, it means it's going to be happening more than once. So that means they're going to calculate your interest 4 times a year. They'll calculate your interest after 4 months. They'll say, hey, this is how much interest you have, so that your bank account goes up.
Oh, I
Then they
get
compound,
it.
then they check your interest again, and they
So
do it again.
They like take the interest of that interest added.
Yep.
Okay.
Yeah, that's what it's doing. Come on.
Does the T ever change? Because you're just doing it times 1.
You could say after 10 years if you want. And this probably just said your T value is 1, and they wanted to know what it was after 1 year.
So then you make 1,083,000
That's like-
per
Go by how
day.
the bank does it, they have a
Well, they're just leaving it at the 0.43. Well, you guys have all seen Office Space, right?
No.
This, you have not seen Office Space? Are you kidding me? No, we can't watch it in class. It's not appropriate for class. But
I might have watched it.
this is how they made all their money. The bank's never going to round up and give you any of your change, because here you've got, thousandths of a cent. Well, what they did is they truncated some of the calculations, and all of a sudden, boom, they had a lot of money. It's a great movie. Great movie.
I don't remember if I watched it or not. My parents definitely have it. Or
It's awesome. I love that movie.
All right, I'm
And
bringing it.
then the last one, we do the 365. What was your value?
1,083.
What did you guys get?
What?
1,083 and how much change?
28
cents?
20 is good if they don't round up.
Does that make sense? Really, really easy stuff to work with. Okay? Now, when you can change your value of time, let's just do one of these real quick. Here's where they're saying that the value of time is different. In this case, it's after 2 years. See how that just changes? So if you deposit $500 in an account right now, pays you 3% annual interest, find the balance after 2 years. If the interest is compounded, let's just do quarterly.
So
And we'll go-
500 times 1.
Let's just do this one. In that problem, what's your initial amount? 500. So your p-value is 500. What's your rate? 0.03. How many times are we compounding?
4.
And for how many years? 2. There you go. You put all that in your calculator. Then it spits out a number.
53.07994239.
Sure.
Good job, Tom.
Right.
That's how much.
So let's see, 500 parentheses 1 plus equals.
No, 53. Oh, I
Was it-
it's 50, my bad. Actually.
$530.80.
That's why you always double check, because he's wrong.
Don't let him do your taxes.
That's a bit. I didn't even notice that.
Like I said, guys, the word problems when we work with these things with exponential growth and decay, they're really, really easy. There's not a lot of craziness involved here. Let me show you an example.
The one where the compound interest with that.
I got it, son, guys.
What do you mean?
Like, say that you borrow.
That's a different way of doing it. It's different.
So you
That's-
set it up differently?
Yeah, that's a different style because it's not an exponential style when you're paying back a loan. It's a little bit different. There's a different formula. Yes, ma'am. Oh, no, good conversation. Exponential decay. The only thing that changes, it's 1 minus the rate. Okay? So your growth is 1 plus the rate. Your decay is your initial amount, 1 minus your rate to the t.
And the same with the next one.
There really is no exponential decay as far as principal and interest, because that means you're earning money and stuff, you're not losing money. When you're losing money, you're using the decay, and that's your depreciation. And this is where the car stuff comes into play again.
How do you drive it off the line?
Yeah, the moment you drive it off the lot. Some cars depreciate faster than others. Some cars appreciate differently than others. There's usually flow to some of that. To be honest with you, the cars that depreciate the fastest, do you guys know which ones those are?
The most
No.
expensive.
Not necessarily. Let me ask you this, what brand depreciates the quickest? Dodge. Dodge and Chryslers.
Why?
Why?
To be honest, because they're usually not rated very well.
What does that mean?
They're not as reliable and stuff as, like a Toyota or
The best is Honda.
Hondas and Toyotas, they don't tend to depreciate as quickly. Trucks tend to depreciate a little bit. Nowadays, trucks depreciate a little bit less than they used to. A few years ago, when gas was like $18 a gallon, SUVs would depreciate tremendously. SUVs, I mean, they were just nuts. When we bought our Suburban, I think gas was hovering right around $3.50, so we got a steal on our Suburban. It's a good conversation on that one, right? I don't drive that anymore. I have a truck. It's much nicer.
It's kind of true.
We use it, Robert. Yeah. That's all it is, but I like that better anyway. So let's look at this. Oh, it's the same. They're all the same values. The A, the R, and the T, they all stand for the same thing. It's all the same. Hey guys, real quick. In your decay thing, the A, the R, the T, those things all still stand for the same thing in decay. Bless you. They all stand for the same thing. It's just a matter of how they set up, okay? So when you're looking at a depreciation value, you're buying a new car for 24 grand. You buy a car for 24 grand anymore?
Yeah.
One of those big plastic Barbie Jeeps.
So you buy a new car for 24 grand. The car decreases in value by about 16% each year. So we're going to write out the exponential decay model. I'm not going to worry about graphing these things. Graphing the exponential growth or exponential decay models tend to be kind of messy because they're not very clean when you put them on a regular 10 by 10. So we're usually going to skip this step.
Yay.
Plus you have your calculator. I'm not going to take your calculator away when you have to do the modeling stuff. Okay. So let's use the calculator to, instead of saying the graph, let's use the table. So if my initial amount was 24 grand, I'm depreciating at 16% a year, what's my model going to look like? Well, what's your A amount?
24.
What is your rate?
0.16.
And our time, well, we don't know. So we write out our model, y equals our initial amount, 24 grand, 1 minus our rate, to the t.
So we're just gonna put that in the table then, or?
Yeah, and so we want to see what the value of the car is going to be worth after 2 years. If I put that right into my calculator, I'm going to go right to the y equals part of this in this example. The reason I'm going to my y equals instead of just putting the answer in the calculator is that I could set that up and just look at my table for all the different t values of years.
12,000, right?
Wait, so,
It's 4 years.
Well, 1 second. What's that?
wait, so how do you, so how do
You use x. Okay. If you look at your calculator, it has x, t, theta, and n. There, it's just a variable. Okay. So is it y equals 24 grand times 1 minus 0.16 parentheses to the that.
At least I think I got it this time.
So after 2 years, notice year 0 the car was worth 24,000. After 1 year, it was what 2160. At 2 years, 16,934. Yes, ma'am.
Are these all rounded?
These probably,
Yes, they are.
I think so. It depends on how my setup on my table is.
12,000.
So you're looking at that.
2 years, it's 16,900.
You guys, when you have car loans, if you're financing a car at $24,000 a year, you're paying on that. You're obviously probably not going to have it paid off. Usually car loans are 4 or 5 years in that range. Normally what happens is it takes longer to pay off the loan to what the car is worth. It's called being underwater. You ever heard of that before?
Yeah.
A lot of mortgages were like that, or recently when the values tank. You're underwater in your mortgage. Your house is worth less than what you owe on it. Everybody's just like that for a long time. Well, it is a lot. This is where a lot of this comes into play. So these little formulas and stuff allow you to tell, what's your car going to be worth? Do you know what the depreciates and all that kind of stuff. Now, what they asked us then, how many years would it have to be about $12,000? Well, about 4 years. About after 4 years, it's going to be worth about 12 grand.
What's the interest rate though?
Well, it also depends on the car. There's certain used cars are worth more than other ones in the range. It's all weird how they set all that stuff up. It's all really, really weird.
I'll just go there. 21
But like,
years
just
ago.
like in general.
Yeah, Our Jetta just turned 100,000 miles the other day. Wow, it's great. Yes, ma'am. All right, do this one. You're buying a stereo system because that's what people do. They go and buy systems, man. Look at these awesome speakers.
I got a speaker. No, serious.
Your stereo system you bought it for $780.
Oh, they take out a
Why would you
speaker.
spend
Yeah, I
that
think we just
much?
probably got.
No, we're about to start.
Not necessary. What is it just a sheet?
Yes.
Yeah, there's.
Right off the equation of this, I forgot, I might have cut off the other part of the problem. Let's write out the model. Then we'll figure that out from here. Yes, back in the day, people actually bought full-on component systems. I know, they weren't just a sound bar and a subwoofer. They actually, you actually had to buy what's called an amplifier and an equalizer. I know these are weird words that someone may not understand. You might have had to get what's called a receiver. A receiver.
All this stuff that doesn't work.
I have the original CD player my dad bought when they first came out. I still have it. It works fine. It's 30 years old, maybe.
You should get some big old stuff in your truck. I can see this very
I will say one thing. What's nice about the stereos nowadays in cars, the stereos that they come with are really good. They're really, really nice. I mean, the one we had in our Bourbon, this Bourbon had like 12 speakers in it because they're just everywhere.
Yeah.
And then even in this truck, there's still a ton of speakers. It sounds awesome. I mean, they're all Bose nowadays in the trucks and all stuff. Anyways, we start this one out at $780, decreasing it 0.05. Pretty easy. One of the things you will see in some of these word problems is that they'll write out this. And it'll ask you which one's growth, which one's decay.
The first one's growth, the second one's decay.
Why?
Because it starts out at 1 and then it's multiple, so
Everybody hear the difference between growth and decay here? The growth stuff in parentheses will always be greater than 1. Decay stuff will always be less than 1. Pretty difficult, huh? Okay. I just made it up. It's not like I was really trying to do something right. Let me give you some of these to try out.
Oh my gosh.
That's like the cars were. That is a year 3014. It's worth, you have to pay 5 times 2.
Alright, yeah, now we're waiting.
Well, at this point, it's birthday on Friday. Bronze can be still worth some. I know that won't ever money. I mean, or like, once that they sell somebody, you know? Oh, that is
Are you waiting to put evens and odds?
No. Seriously. They're that fast, guys.
Alright.
They're really, really, really easy.
Really stuff we just did, right?
Yes, sir.
Alright.
Yes, sir.
How
So
last one this takes me like 2 hours.
it's not going to take 2 hours. It might take you 20 minutes.
Can I get it done next hour?
Should be able to.
Are you gonna get it done in what?
Remember, there's parts in here where it says to graph them. Don't worry about graphing any of them. If it says to graph, just skip that problem because each one of these has separate parts to it. You know, if you're looking at,
Did you mean to write down 46 and not 47?
I don't know. If I'm looking at this one here for the decay, this is 8.2. They're giving you the decay model. What's the initial decay amount, percentage decrease? Graph the model. You don't have to do the graph. Just use the formula to figure out when it was a million. That kind of stuff. Very, very easy to set up. Okay. What's up?
If you look at it for K1, oh, never mind.
It's your fault, not mine. Sorry.
Guido, you're al baño.
Es posible. Necesita. Cállate la boca. Espanol is whenever you want to.
Wait, are we watching this like all the
Tango, dos zapatos. I have 2 shoes. Oh yeah, stuff next year.
Take